Assalamualaikum and salam sejahtera. My name is Farah Najwa Binti Zakaria. Today I would like to discuss about chapter 28, which is carbohydrate. What is carbohydrate? Carbohydrate is a commonly referred to as sugar and starch, polyhydroxyaldehyde and ketone, or compound that can be hydrolyzed to them. Most sugar have formula CnH2ON, or we call it hydrate of carbon. Carbohydrate can be synthesized by plant using sunlight to convert carbon dioxide and water to glucose and oxygen. Glucose is the example of the carbohydrate. There are three classifications of carbohydrate, which are monosaccharide, disaccharide, and polysaccharide. What is monosaccharide? Monosaccharide is the simplest carbohydrate or simple sugar. They have 3 to 7 carbon atoms in a chain. The carbonyl group is at either the terminal carbon at C1 or the carbon adjacent to it, or C2. If the carbonyl at C1, we call it aldehyde, but in the carbohydrate, we call it aldose. If the carbonyl at C2, we call it ketone, but in a carbohydrate, we call it ketose. For example, D-glyceraldehyde, we call it an aldose because they have carbonyl at C1, and dihydroxyacetone, we call it ketose because the carbonyl is at C2. A monosaccharide is called a triose if it has 3 carbons, a tetrose if it has 4 carbons, a pentose if it has 5 carbons, a hexose if it has 6 carbons, and so forth. These terms are then combined with the word aldose and ketose to indicate both of the number of carbon atoms in the monosaccharide and whether it contains an aldehyde or ketone functionality. Thus, glyceraldehyde is an aldotriose because it's an aldose and have 3 carbons. Glucose is an aldohexose because it aldose and have 6 carbon, and fructose is an ketohexose because it is ketone and have 6 carbon. Next, we will discuss about the Fisher projection. Normally, we use Fisher projection to draw the carbohydrate structure. There are 4 criteria to draw the Fisher projection. Firstly, a carbon atom is located at the intersection of the 2 lines of the cross. The horizontal bond comes forward on wedges. The vertical bond go back on dashes line. The aldehyde or ketone carbonate is put at or near the top. Next, we will discuss about the Haworth projection. To convert an acyclic monosaccharide to a Haworth projection, you should follow a stepwise procedure. Step 1. Place the O atom in the upper right corner of the hexagon and add the CH2OH group at the first carbon counterclockwise from the O atom. Step 2. Place the anomeric carbon on the first carbon clockwise from O atom. That's it. For an alpha anomer, the OH is drawn down in a D sugar, and for beta anomer, the OH is drawn out in the D sugar. Step 3. Add the substituent at the 3 remaining stereogenic centers clockwise around the ring. The substituent on the right side of Fisher projection are drawn down and the substituent on the left of the Fisher projection is drawn out. To convert a Haworth projection to a chair form, we have 3 steps to follow. First, draw the pyranose ring with an O atom is an up atom. The up substituent in the Haworth projection becomes the up bond, either axial or equatorial on a given carbon atom on a Hooker seed membrane, and the down substituent in Haworth projection become the down bond, either axial or equatorial on a given carbon atom on a Hooker seed membrane. Next, we will discuss about the reaction of monosaccharide. Because monosaccharide exists in solution in an equilibrium between cyclic and acyclic form, they undergo 3 different types of reaction. First, reaction of the hemiacetal. Second, reaction of the hydroxy group. And third, reaction of the carbonyl group. This is the reaction mapping for the reaction of monosaccharide. Treatment of a monosaccharide with an alcohol and HCl convert the hemiacetal into an acetal called a glycoside. Treatment of alpha-D-glucose with CH3OH and HCl form 2 glycosides that are diastereomer at the acetal carbon. This is the mechanism for glycoside formation. Firstly, the OH group at the anomeric carbon is attack the hydrogen from the HCl to form OH2+. The OH2+ is left as a leaving group to form the resonance stabilized cation. The nucleophilic attack can occur in 2 different ways, which are from above and from below. If the nucleophilic attack occurs from above and deprotonation occurs after that, it will form beta glycoside, and if nucleophilic attack from below and followed by deprotonation, the product form is the alpha glycoside. Next, we will talk about the glycoside hydrolysis. Unlike cyclic hemiacetal, glycosides are acetal and so that do not undergo multirotation. Glycosides are hydrolyzed with acid, not in base, and water to cyclic hemiacetal and a molecule of alcohol. A mixture of 2 anomeric is formed from a single glycoside. The mechanism of glycoside hydrolysis is just the reverse of the glycoside formation. This is mechanism for the glycoside hydrolysis. First, OCH3 is attack hydrogen from the H2O+ to form CH3OH. After that, CH3OH is left as a leaving group to form the resonance stabilized carbocation. The nucleophilic attack can occur in 2 different ways, which are from above and from below. If nucleophilic attack from above and followed by deprotonation, it will form beta glucose. If nucleophilic attack from below and followed by deprotonation, it will form alpha glucose. This is the application industry for the cardiac glyphosate. It is used to treat congestive heart failure. Next, we will move to the second classification of carbohydrate, which is disaccharide. What is disaccharide? Disaccharide contain two monosaccharides joined together by the glycosidic linkage. The general feature of disaccharide including the following. Two monosaccharide rings may be 5 or 6 members. The rings are connected by the O atom that is part of the acetal or glycosidic linkage, which may be oriented alpha or beta. The glycoside is formed from the anomeric carbon of one monosaccharide and any OH group on the other saccharide. All disaccharides have one acetal together with either a hemiacetal or other acetal. With pyranose ring, the carbon atoms in each ring are numbered beginning with the anomeric carbon. Primes are used to designate the atoms in the ring that do not contain the glycoside. The most common glycosides are formed from 4' OH group. There are three naturally occurring glycosidic linkages. Firstly, 1,4' link. The anomeric carbon is bonded to oxygen on C4 of the second sugar. 1C' link. The anomeric carbon is bonded to oxygen on carbon 6 of second sugar, and 1,1' link. The anomeric carbon of the two sugars are bonded through an oxygen. Next, we will discuss about the last classification of carbohydrate, which is polysaccharide. Polysaccharide contain 3 or more monosaccharides joined together. The three most prevalent polysaccharides are cellulose, starch, and glycogen, each of which consists of repeating glucose unit joined by different glycosidic bonds. This is the example of polysaccharide. This is the summary of this chapter. The carbohydrate can be drawn as Haworth projection, Fischer projection, and chair formation. For the reaction of monosaccharide, it involves the hemiacetal, which are glycoside formation and glycoside hydrolysis. The reaction of monosaccharide at the OH group, including ether formation and ester formation. This is reference for this chapter, which is I refer most of the slides from the Organic Chemistry 5th edition textbook. So that's all from me. Thank you very much.